All right, good morning, everyone. I hope everyone's having a great day today. It's good to be back. It's always good to be on campus, especially after we weren't able to be. It was a really bad storm. Hope everyone is doing well with all that. Just a reminder to everyone, the Connect Master for the cybersecurity chapter is due tonight at midnight, so 11:59 p.m. technically. So make sure you submit it by then. I'd encourage you to do it earlier than that, of course, but 11:59 p.m. is the absolute deadline there. Beyond that, we're going to be covering Chapter 5 today. Chapter 5, we're talking about data and knowledge management. Today's lecture is going to cover a lot of the theoretical parts of it. And then in next lecture on Thursday, we'll pick up with some diagramming that you'll need to know, not only for the class, but also just in general. So that's what we're covering today. Specifically, we're going to start with talking about how organizations manage their data. What sort of data they have, what they do with it, and why they do what they do, basically. We'll talk about the main way they do that, of course, is through a database. So we're going to get into some details about that. And we're going to cover information about big data as well. I'll talk about what it is and, again, why it's used. And then, of course, we'll cover data warehouse and data marts. It's another important topic for today. And last topic we'll cover today is knowledge management. So we're going to do the diagramming and all that next class. So let's kind of start off. Organizations have a tremendous amount of data. They have data about their customers. They have data about their suppliers, their inventory, their sales. They have just any piece of data you can imagine. They have data about every person who's ever applied for a job there. Well, they should at least. They probably have data about that. Just a tremendous amount of data. So that opens up a lot of interesting questions. Number one, where are you going to put all the data? Number two, how are you going to effectively and quickly access the data that you have to gain the insight that you need to gather? Some other questions to address with this. Who can access what type of data? You don't want to have every single piece of information your organization has be freely available to everyone. A lot of reasons for that. Of course, one of the most basic reasons is that's not going to be very secure. Think back to the security chapter. The CIA triad. Which one of those letters do you think would most likely reflect that? It should be the confidentiality aspect of information security. So it's the same sort of thing. We have those same goals when we're talking about data governance. Data governance is all about the organizational policies surrounding the collection of data, the dissemination of data, storage of data, anything to do with how data is used, how it's collected, anything like that. We're going to have policies in place. This is going to vary by organization. Generally speaking, we're going to have some sort of statements about where the information will be stored, what sort of format it will be in, all that sort of stuff, because that's vital to know. If we don't know how the information is going to be stored, how can we access it? So let me rephrase that question a little bit. If we don't know how our information is formatted, and we don't know what information is inside of which table, it's going to be very challenging to be able to make any sort of sense of what we're talking about. So again, just like with the ethics sort of guidelines, we have data governance. So that's where we're going to really codify a lot of the standards that we use as an organization, and as opposed to just having it be anyone who wants to input data inputs it however they wish, we as an organization come together and we form some sort of data governance standards that are going to go across the organization. So lots of legal reasons to have it. Certainly want to avoid any sort of liability issues. Also want to avoid regulatory issues. A lot of industries, finance has Sarbanes-Oxley, education has FERPA, healthcare has HIPAA. There's many others that have large regulations concerning the storage of information and data. So we want to be mindful of that depending on which industry you're in. So with all that in mind, we also have this concept of master data. So master data is simply going to be a collection of the data that is very central to our organization. So this has stuff about who our customers are. This would have stuff about who our suppliers are. Any of that sort of stuff. Generally speaking, this is going to be a lot of overlap with the ERP. So the ERP has all the information. It's going to be considered an organization's master data. Now, it's not to be confused with a different type of data, transaction data. So as the name would imply with a transaction, we've talked about this before, simply going to be some sort of a business transaction, a purchase, a sale, could be other types of transactions as well. maybe writing something off, whatever you may be doing, it's going to be some sort of transaction. That's not going to be master data. Master data is going to be something that changes, but it's not going to change as rapidly as transactions. If you're a large enough organization, you may have multiple transactions occur within a second. You probably would be hard-pressed to find master data changing multiple times within a second. Not to say that it can't happen, it's just less likely to happen. So that's the distinction there. Make sure that you know that. I've got a quick video here. I'm just going to play it. It's kind of a humorous way to introduce the concept of knowledge. So I'm just going to mute myself and change the screen on the record. All right, sorry guys, I had to get the recording back going. So yeah, in that video, you saw where Wally was saying he's a subject matter expert in a field that's so narrow, you don't have to know anything to know everything within inside the field. Is that worthwhile? It's not, because there's nothing to know. So that's just kind of a humorous little way to kind of introduce what we'll talk about. So one of the ways that we can effectively store information, data, and knowledge is with a database. Pretty straightforward. So there's some real advantages that databases provide us. Number one, they're going to be relatively standardized. It's very important when you're considering a database that you pick something that is going to be very easy to interact with other systems. So if you were to pick a database that could only interact with a certain piece of software, you basically just added in a lock-in cost to whatever system you're using. And that could be very problematic if you ever wanted to change, or if you ever needed to change. In addition to that, maybe you don't even want to change, but let's say that the vendor you're going with does not continue to provide support for the product. Well, you may be required to change for that reason. So there's a lot of reasons to make sure that you have a database that's going to be relatively standard. And the good news is most of them will be. So you can interact with them from multiple systems. It's very simple, using stuff like XML and other sorts of tools to easily interface with whichever database you select to use. So some other advantages, though, when it comes to databases. So they are able to minimize three things that are very beneficial for a firm to minimize. First is going to be data redundancy. Now, on a small scale, when we're talking about a database, it may not seem like data redundancy is that big of a deal. So, of course, when we refer to redundancy, we're talking about having multiple records with the same piece of information. So if I had a table, and let's say within inside that table, I had information that's repeated. So let's just think if we had a table with all the courses offered by the university. So, there may be times where you're repeating information within that table. For example, let's say that there's the course BIS 3233. So if you have those two pieces of information, you know everything else you need to know about the course, because that can uniquely identify every other thing about the course. So for example, Business Information Systems 3233 is called Management Information Systems. It also has a catalog description associated with it. I certainly don't have this memorized. BIS 3233 is a 3-credit-hour lecture. This course is a survey of the components, functions, and processes of information systems as they relate to managing modern organizations for increased efficiency and effectiveness. So, would you want to have that repeated every single time that you had some class section of BIS 3233? You probably would not. But think about that on a much larger scale. We're talking about millions of repeated pieces of information. So we're going to cover how specifically we can do that next class. But for now, just understand it's going to help us greatly reduce the amount of redundancy that we have inside of a database. Now, we're talking about why we would want to do that. There's a lot of different reasons. Probably one of the biggest reasons is cost. So we have some database, And generally speaking, we're going to want to have at least 2 copies of the database. Now, why we want to have at least 2? Well, we want to make sure we have backups. So that's going to be at least 1 copy. Hopefully many more than just 1 copy of a backup. But you'd also want to have some sort of a development environment. So if you were to roll out some sort of change, you wouldn't be affecting the production server, and you also wouldn't be affecting your backup. Because let's say you roll out a bad change, okay? And then you don't realize it, so you roll it into production, and then let's say you make a backup. Well, if that's your only backup, you're toast. And that's not what you want to have. So certainly having data redundancy can reduce the cost of the data storage. Because if you're having to store something at least 3 times and you're using enterprise equipment to do so, it's going to be quite costly. In addition to having the data stored in physical locations in 3 different places, you're also going to have redundancy in the hard drives themselves. So lots of different ways to do that. We're not going to cover anything technical in here, but just understand it's very costly to store even a small database in a setting that will be able to be, pretty redundant, pretty available. So thinking back to the goals of information security, availability. If we failed to do this step, we'd have lower availability of the database as a whole. So data redundancy is going to greatly reduce those costs. So if we can save 20% on our storage that we need, that's going to be a 20% reduction in storage costs. Now, will it always directly translate to a linear reduction? No, it will not. Certainly, you're more likely to realize that linear reduction if you're using some sort of software as a service as opposed to owning the hardware yourself. Because, a lot of different reasons. The main reason being, if you own the hardware itself, you have the capabilities no matter what you're doing with them. So if you're choosing to not use the capabilities, you've already purchased the capabilities. Or as software as a service, you can, in some cases, scale back what you currently are using and see some reduction in payment. The other main reason to have this redundancy eliminated, or at least reduced as much as possible, is you are able to more effectively process the data. So if you have less information within a database, ceteris paribus, it's going to be a lot quicker to process any sort of query, transaction, anything that you're doing within inside the database. Of course, there's a lot of reasons for that. The main thing is it's going to go through each of the records. If there's more records that are have more information within inside of them, it's going to take more time. Certainly, and that is when we'll actually, instead of seeing a linear reduction, you'll actually see more of a exponential reduction. So the larger the database, it's not going to be a straight line in terms of processing. It's going to be linear, or it's going to be exponential rather. So certainly, you definitely want to make sure that you're using as little resources as possible to save on cost. Now, when we talk about cost, we're not just talking about the cost of the hardware itself. Think about, other costs associated with hardware. You have to have more people in a lot of cases. In terms of a very large scale, you'd certainly be more inclined to have a larger staff. In addition, one of the larger costs of data storage is not even necessarily just the storage itself. It's oftentimes the heating and cooling and the electricity. So those are actually going to be roughly, depending on the size of the data center, 75 to 90% of your cost. So if you can reduce the amount of processing that you need, the amount of storage that you need, you're going to see cost reduction in other areas you may not would have otherwise thought. So certainly this is going to be a very beneficial thing. Now, it's probably more information you ever wanted to know about data redundancy. Let's talk about data isolation. So data isolation is going to be a problem where you would have data that's going to be available to one system or one functional unit within inside of an organization, and other people don't have access to it. So this is where we talked about with the ERP is able to have a reduction in information silos. Well, it's a similar thing here where the data is not going to be only available to one specific party or one specific software. It's going to be available across the systems. So different systems are able to interact with it, assuming they have the functionality to do so, because it's using, in most cases, standardized languages to do all of the sort of data storage tasks that it needs to accomplish. So data isolation is going to be reduced by having the ability to have those databases that can interact with multiple systems. And then lastly, data inconsistency. So data inconsistency, as the name would imply, is a problem whenever data is entered in a system in inconsistent ways. A very common example of this is an address. If you enter in an address, there's lots of different ways to do it. So for example, let's say you're living in an apartment. Let's say 123 Sesame Street, That's your street address number 1. But then your second line of the address, you could put in as apartment. You could spell out apartment. You could type in 1A. And you could certainly do that. But you could also go up to the street address number 1. Go back up to 123 Sesame Street. You could do a comma, and then you could type in APT space, and then let's just say 1A. You could do 1-A. Whatever you're doing, there's going to be inconsistency associated with that. And that's going to be a big problem because imagine you then wanted to say, I'm going to want to uniquely identify a customer by their address. And if the data is inconsistent, you may not be able to do that. So imagine the data is entered every time, and someone's entering it one way, someone else is entering it another way. You can imagine there's a very large amount of possible ways to enter in an address. So how do databases solve that problem? Well, there's lots of different ways. One of the big ways, of course, would be to associate the user with an account. So they're using an account that is going to have all the data stored inside of a database. They're not entering that information every time they make a sale or a purchase. That's one way. Another way will be to tie this into something like the USPS provides for mailing addresses. And if you type in something, they'll be able to suggest, did you mean this address? And you say yes. And you don't allow it unless it's an address that's recognized by the USPS. Now, there's some issues with doing that, of course. What if someone's address just isn't recognized by USPS? Well, then you don't get them as a customer if that's your policy. So you definitely want to have some sort of override, but at the same time, you'd also want to ensure that you're maximizing the consistency of your data wherever possible. Other ways to do this, of course, are data validation. So imagine I were going to input a phone number into a database. What would I expect to enter? Would I expect to enter ABC, or would I expect to enter 1, 2, 3? Hopefully you'd have numbers in there. So you could certainly have data validation rules to only allow for a specific range of characters. And that's something that's very common, and this is going to also enhance security in some ways. We have things like data sanitation. So we don't allow certain characters that could otherwise cause us problems. It's very common inside of SQL in particular, structured query language. If you're going to do some sort of an injection attack, to use a semicolon, and then type in whatever command you want. Because what that does is that ends the current command, and then it allows you to do a new one. So it's quite common to do something like, if you're inputting information into a database and you're wanting to be a little nefarious, assuming they're not sanitizing the input, put in a semicolon, type in whatever command you want. Could be drop table, whatever table you want to drop. Deletes the table. That's another reason to have data backups, of course. But you can certainly avoid that by using those data validation. Okay, whoops. Sorry about that, guys. In addition to minimizing a lot of problems, it also provides us a lot of benefits. It's a benefit to minimize problems, but it's also a benefit to provide additional benefits. So I just kind of talked about the data security aspect. In addition to sanitizing the input, that's certainly an advantage. But I'd say other advantages include the ability to encrypt information. Can you feasibly encrypt printed information for most organizations? You cannot. How do you secure printed information? You use a physical lock. Physical locks can be great, but most of the time when you're talking about a filing cabinet, does it have a very secure lock? Probably doesn't. So it's not going to have as high security when you're talking about physical. So certainly databases can be encrypted. They can be stored in a secure environment. It's going to have a lot of advantages. Not to say there's no downfalls of that. Certainly none of this is going to be foolproof. A lot of it comes down to user accounts themselves. I think something like over 60% of attacks are going to be using some sort of a corrupted user account. Data integrity. Making sure the data has proper integrity means it's accurate. It means we're not having any sort of problems. That's one of the good things. There's not going to be any human, well, I'm not going to say there's not going to be any human error. We're going to be able to reduce the amount of human error when we're using databases for processing instead of pen and paper for processing. A lot of reasons for that. The main one being there's going to be a lot less interaction. If you program something to do what you tell it, it's not going to do anything other than what you tell it to do. Now, if you tell it to do the wrong thing, that's going to be a problem. But assuming that you don't tell it to do the wrong thing, you won't have any issues, barring any sort of, well, there will be some cases, but for the most part, it's going to have reduction. We're not going to get too much into the technical aspect here. And then lastly, data independence. Like we talked about, the data is not tied down to any specific system. So certainly these are going to allow us some very important advantages. So I talked about SQL, and that's going to be a type of a relational database. So we're talking about a relational database. All we're saying is a database where it has tables that have relationships with other tables. So this is going to be very widely used in businesses today because it's very simple to understand in comparison to other types of databases. Typically, this is what's going to be taught in most business courses. But the thing is that relational databases take a lot more processing power than other types of databases can. So there's non-relational databases that are going to be able to perform faster processing. And if you're a company, Uber is a famous example of this, where they had a relational database, it wasn't able to keep up with the amount of billions of transactions that were occurring. They weren't able to have what they needed, so they had to move to a non-relational solution. But the whole concept is that you're typically going to be inputting data in a very standardized fashion. So we're going to cover a lot of the specifics with this next class when we actually do the data modeling. But for now, just know that generally speaking, you're going to have some sort of a database management system. It's going to be able to interface with the database and allow for simpler commands to be run, allow for simpler data entry, simpler stuff like that. So again, we're going to skip a lot of this for now. We'll come back to it next class. Okay, let's shift gears a little bit then and talk about big data. So far we've talked about databases themselves, talked about some of their advantages, talked about some problems they solve, and one of the big things they introduce is the ability to handle big data. So what is big data? Well, it's simply going to be data that has a large size. No, that's not the definition. It's really going to be large unstructured data. So this is going to be any sort of data we're getting on a very massive scale. It can be terabytes of data. This can be even larger than terabytes of data. And there's really three major components that we want to talk about here: volume, velocity, and variety. And go through each of these. So first we have volume. So if you would imagine with volume, it's how much space does the data take up. So that's going to be expressed in some sort of a byte. So it could be a megabyte, gigabyte, terabyte, whatever we wanted to use. That's how we're calculating the volume. How much space is it, physical space does it take up? Then of course we have velocity. So as you'd imagine with velocity, how often is the information changed? How often is it added to? How often is it updated? How often is it removed? That's all going to be factored into the velocity. So it's not really a unit for this. It's more of a sort of a qualitative measure of how often is something updated. But it's not like I can give you an SI unit and say, yes, it's bytes per hour or something like that. So no real unit there. It's more of just this is how often I think. And then lastly, variety. So variety is probably the toughest thing to deal with, because what variety is it's saying how different is the data inside of the database. So we already know it's unstructured, but how unstructured is it? In other words, do we have just a large data set with just completely different types of data, or is it somewhat similar to the other data? If it's completely dissimilar, it's going to be very difficult to interact with it and gain any sort of insight from it, because the first thing you have to do is get it in some sort of format where it's even possible to run any sort of analysis on it. So that's certainly something to keep in mind, but that's not to say that, if we have a completely very big data set, that we couldn't do anything, we couldn't gain any insight from it. We certainly could. So here's some examples of big data. Traditional enterprise data, probably not the best example of big data. The reason for it being it's going to be highly structured. We have that sort of very rigid structure applied to an enterprise, and see, these are our list of vendors, these are our list of customers. That's very structured data. So that's not the best example here. A better example would be machine and sensor data. So this could be a lot less structured. It's very common to have a sensor, and it could produce, let's say within 1 hour, it could produce thousands of observations. And you may have a machine, and it may have 50 sensors. It may have 500 sensors. Just a tremendous amount of sensors. And, you're looking at just a couple hours, you could have gigabytes worth of data from one machine alone. And that would certainly be something that would be very challenging to store and very challenging to gain any sort of insight from, because the data is changing very rapidly. So generally speaking, if you're dealing with a situation like that, you would tend to look for exceptions. You tend to look for something that was different from what you would expect. So for example, let's say you have a motor. And let's say all of a sudden you notice that the temperature is rapidly rising. You wouldn't necessarily care what the temperature was for 2 hours, but you would certainly care if you had an exception to what you believe to be a reasonable temperature, because that could be indicative of a problem. Certainly if you had a problem, you want to be able to solve the problem. So that's all we're talking about there. Social data. This, of course, is talking about social media. So if you think back, I think it was, maybe it was last class. I don't remember exactly. We talked about getting direct feedback, how to solicit it from customers. Easiest way is going to be social platforms, because people will give you the social data, and then all you have to do is just run some sort of sentiment analysis on it and get a pretty good idea of what people are thinking about a product, what people are thinking about some sort of a trend, maybe a hashtag, whatever the case may be. Have a pretty good idea. Of course, what's one of the problems with doing that? Well, there's going to be a huge problem of selection bias, where people who maybe don't care, or maybe the platform itself is tilted in a way that wouldn't be representative of the population as a whole, that can certainly be a very large problem. So certainly keep that in mind, and don't necessarily take it to be, the only truth that is available. Images. So if you had a large data set containing a bunch of images, it'd be very challenging to get a lot of information from it. Luckily, we have various image analysis tools we could use that would allow us to see various things associated with it. Facial recognition is another thing we could do. See if we recognize faces. That can be very advantageous for a firm to be able to do that sort of stuff. That's one of the cool things about a lot of the facial recognition tools available today, particularly ones available via providers like Amazon and Facebook, is that they're able to use social platforms to see faces. And then they're able to tie those to whatever sort of facial recognition that you wanted done. So very cool, and potentially also a little bit scary, but I'll leave it to you to decide what you think of it. Then any other sort of media where we have just a large amount of unstructured data, we're going to be able to do some sort of analysis. It may not be what analysis we'd like to do, but there's always going to be something we could do. So, of course, with this, you can imagine there's going to be a lot of potential issues and drawbacks. So the most obvious drawback being, big data, by the name big, means it's large. You have to find somewhere to store it. And could also be updated very rapidly. So not only would you have to find somewhere to store it, you have to find somewhere to store it that can expand and contract as needed. And beyond that, somewhere with a large amount of network capacity to be able to handle data that's constantly changing in size, constantly having new sorts of things occur to it. So that's a very big problem. But that can be addressed pretty easily, luckily. And then beyond that, of course, we also have the problem, what if the data source we're getting data from is not a good data source? What if it has malicious intent? What if it has inaccurate information? We don't necessarily know that the data we have, especially with big data, we don't know that it has integrity. So if the data we're collecting, it doesn't have integrity, what does that mean? Well, it's like we can average it, but what does that mean if we average something that we don't know whether it's accurate or not? What does the average mean? It doesn't mean anything. So it'd be very difficult to gain any sort of meaningful insight from inaccurate data. Beyond that, of course, dirty data. That's data that would be very unstructured, very varied in what it contains. So again, there are certain ways we could gain some sort of insight and see certain trends and stuff, but generally speaking, we're not going to be able to really tell a ton from that sort of data that's going to be formatted in that way. So those are some big issues. Let's talk about what it can be used for, though. So one of the most common examples is going to be some sort of experimentation. And this could be any sort of experiment you can imagine. It could be an experiment where you roll out a website, and you're wanting to roll out at least 2 or 3 different versions of the website. So you roll out the first version to a subset of people, roll out the second version to a different set of people, and kind of compare and see what happens. That's one use. That's one type of experiment. But there's really lots of different types of experiments we could do. So certainly don't use that as your only example. That's just one common example. Beyond that, of course, we can do microsegmentation of customers. So it's very common for firms to be able to purchase data about people in general from some sort of data broker. Data brokers are an interesting breed. I've worked with them a little bit for some of my research, and it's very costly, but it's also worth it to companies. Because imagine if they can get a list of people, let's say they're operating within one specific geographic area. Let's just use Starkville as an example. You go to a data broker and say, I want all the information you have about Starkville. And you can get it. It's costly, but it can be done. So then you'd have all the information that they would have access to. A lot of times it's going to have any sort of purchasing history, particularly with credit cards, reward cards. Basically, one of the benefits you're getting of using them is you're getting some sort of a discount, you're getting some sort of cash back, whatever the case is. But then they're getting the ability to sell your information. So whether that's worth it to you or not, it's kind of up to you, but it does certainly occur. Then, of course, social platforms certainly have their data brokers as well. So lots of information available out there that allows you to better tailor your product and service to a specific individual. And that could be certainly something that could be beneficial to the firm because it can allow you to increase revenue, increase your profitability. It can also be beneficial to the individual. It's always good to have products and services that are offered to you that you like. But it can also be harmful to the individual in that certainly some privacy concerns are, pretty obvious there. Creating new business models. So this could be done a lot of different ways. Certainly simulation, probably going to be a very common approach here, where you just kind of simulate what a price change would do. So in other words, you'd run lots of different simulations for lots of different prices and see how likely is it people would purchase something at a given price. And of course, the goal there would be to maximize your profit. So if you had a product that had a very high elasticity of demand, you'd be able to adjust the price, and depending on where you want it to be, you'd be able to maximize your profitability. So lots of different ways we can use big data. Those are just some examples. Let's shift gears a little bit now and talk about data warehouses. So a data warehouse is going to be something that's going to be across the company. And it's going to be able to have some sort of analytics platform where we can easily sort of see what each thing inside of the company is doing. So this is going to be allowing us to do just tremendous amounts of analysis very easily because we have all the data stored inside the data warehouse. So this is going to contrast a little bit with a data mart. So you think about a warehouse, then you think about a mart. Warehouse is going to be very large, probably larger than this room in a lot of cases. But a mart, could just be a couple hundred square feet. So certainly much smaller. Well, just like this, with a data mart, it's going to be similar in what it does, similar in what it holds, but it's going to be somewhat scaled down. And it's only going to be for one specific business unit or one specific functional unit within inside of a firm. So imagine the accounting department had a data mart that had information pertinent to them, and that's kind of what that. Now, of course, what's the problem with that? That's the information silo. But the goal is that over time, the data mart will adapt and will hopefully transform into a data warehouse that is used across the organization. Does that always happen? Of course not. But it does happen in some cases. So when we're talking about data warehouses, it's important to understand they're going to have lots of different information in them. This information is going to be done in a way that it's going to have different tables. Of course, the tables are going to be organized by subject. So all these sorts of information, it's just going to be very easy for us to then go through and do whatever sort of processing we needed to do. So there's lots of different ways to kind of go about that. Whatever processing, whatever sort of analysis, it really depends on what you need to have done. So if you want to see a specific location's sales, you could easily do so. If you want to see a specific product's sales, you could easily do that as well. There's certainly no real limitation there as to how you would actually use the information. One of the most important parts, though, is that this is all going to be time variant. So time variant meaning it has a time component. This is not going to be some sort of static information. This is going to contain information that is relevant to whichever time period we're wanting to have. Otherwise, we can't really gain a lot of insight because do organizations stay the same for 100 years? Think about Sears. Sears is a good example of this. 100 years ago, are they the same company they are today? They're not. Was Walmart even a company 100 years ago? I don't think so. I could be wrong about that, but I'm pretty sure they were not. So companies don't stay the same. So having time variant information is going to be able to kind of better see what sort of trends are happening over time. Is the sales increasing? Are the sales decreasing? What does that mean for the company? Lots of questions we can answer with that. Non-volatile. So non-volatile is an important component there because if it were volatile, it could certainly cause us problems where it could be updated without being able to, without a proper consent. So that would lead to certainly some issues with integrity. So imagine if you could just go into one single place and you could change all the transactions. Would that be a good thing? No. So of course it would not. So the reason it's non-volatile is so that can't happen. So instead, to change all the transactions, you'd have to go back to the original source. So this is actually going to be able to be sourced from wherever the transactions originally originate from. So not going to be inside the data warehouse itself. It's only pulling the information and aggregating it. Or, yeah, aggregating is probably the best word there. Instead of actually then having the ability to change any individual record. Have to go back to the original source for that. And then lastly, multidimensional. Just like with a time variant, it's not just limited to one specific thing. You can then break the data down however you need to. It's organized in a great way to allow for that. So, any questions so far about today? All right, got another quick little video here. Like I said, I'm going to have to mute everything, so give me just a second. All right, so that's just a little video I like to have, kind of illustrate that there's a lot of things that are going on there. So number one, they had a tremendous amount of information. Now, Dilbert there called it knowledge, but is that truly knowledge? I'd make the argument it's not. So let's go ahead and first distinguish data from knowledge from information. So data is just going to be any sort of raw facts. It could be we made sales of $10 today. That could be a piece of data. But the information is something meaningful about that. We could say we made sales of $10 in one day by doing this. And then the knowledge is actually applying that into practice. So certainly, that's basically what we're saying there. And then, of course, we're talking about knowledge management. So knowledge management, what are we actually managing? What is organizational knowledge? Well, it's a lot of different things. But generally speaking, it's going to be information that the organization has gained over time. So most of the time what we're talking about is how to do stuff inside the organization. So we have one system. We have information about how to update the system, how to use the system. We'd want to have some place to put that. Of course, we'd use a knowledge management system for that, where we'd place lots of different knowledge-based articles inside the knowledge management system. Allow for easy access and retrieval, not only easy, but efficient access and retrieval of that information. So it's very important for organizations to not sort of be redundant in what they do. So imagine there's a company and they ran the same experiment over and over because they forgot what their results were. Would that be efficient? No, it would not. They'd probably go out of business pretty quickly if they do the same thing over and over. So you certainly use knowledge management systems to alleviate that issue and make it less likely that organizational knowledge is lost. So generally speaking, we have some sort of intellectual capital. And that intellectual capital, a lot of times, it's going to be some sort of ways to do things. But it could also be intellectual property. So if we had patents, if we had IP, if we had anything like that, copyrights, we'd want to put that inside an internal system, especially what we have in progress. And then once it's ready to be published, of course, we'd send it off to the U.S. Patent Office and take care of all that. But there's really two main types of knowledge that are important to kind of distinguish. So we have explicit knowledge and we have tacit knowledge. And explicit knowledge is going to be some sort of thing that can be learned as a hard fact. So if I said to you, this class is called BIS 3233, that's explicit knowledge. You certainly can't really argue with that. I mean, it's a fact that it is called BIS 3233. But then if I said, I think this class is easy, or I think this class is difficult, or I have a feeling there's a pop quiz coming up. There's no pop quizzes in here, by the way. But that'd be a tacit thing, where it's formed more by experiences. So it's certainly not something that is going to be empirical, but it is going to be something that can be accurate. A lot of times we think of this as a gut feeling. So I feel like it's going to rain today. Or I looked at the weather forecast, there is a 78% chance of rain today. I don't think there is a 78% chance, but you get the idea. The 78% chance of rain, that's explicit knowledge. The weather forecast, in fact, says that. You feeling like it will rain, that's tacit knowledge. Certainly, there's going to be nothing you can really do to back that up. So those are two types of knowledge. Now we're talking about what goes inside of a knowledge management system. You can really only put explicit knowledge inside of a knowledge management system. Why is that? Well, how are you going to record what you think about something? You know, it's very difficult, if not impossible, to do so. So certainly want to keep that in mind. And, you know, I'm not here to say one is better than the other, but a lot of cases, tacit knowledge can be quite accurate. You know, if someone's been let's say, a loan officer at a bank for 20 years, you know, someone could walk in, they could start speaking about what they're wanting for the loan, and the loan officer may have a pretty good idea of whether this person will or will not be approved for the loan ultimately. That's tacit knowledge. But then, you know, of course, the explicit knowledge would be the things like, what sort of income do they have? What do they plan to do with whatever they're purchasing? What sort of down payment? All that sort of stuff would be more explicit knowledge. So I've got the knowledge management, or the knowledge life cycle here. I don't expect anyone to memorize this, but it's interesting to see the sort of approach that firms take, and this is not necessarily tied to any particular firm, but just in the general sense, what approach firms take to acquire and to disseminate knowledge. So up here, one of the first steps here is going to be external knowledge. So it wouldn't make sense for a firm to start up and to just say, we're going to start everything from scratch, because that's going to be very costly, and you're also probably going to end up getting employees who would be versed in the way things could be done already, who would not be versed in whatever sort of things you develop. So not only would it be costly to develop, it'd also be costly to train people on it. So there's going to be some external knowledge component associated with it. But then beyond that, you know, in most cases, a company's going to have some sort of thing that they can't just use whatever's out there already. So that's the acquiring phase, where they're going to obtain and grasp new knowledge. So this is where they're actually going to form something, whatever they're doing, you know, just kind of understand. They're acquiring new knowledge. Could be they're looking it up, could be they're making something up in their minds, whatever. Then they take that knowledge, they apply it. So they're going to fit that knowledge to whatever specific problem they're dealing with. Could be a new business idea, could be a new product idea, whatever the case is, you're going to apply it. Then you assess it. So you see, was that knowledge meaningful? Did it provide good results? Did it make a huge flop? Whatever the case is, you want to see how effective that actually was. So then, of course, you do the creation, where you actually then sort of fill in that knowledge, replace it. You just kind of go through this. You get to the refine phase. You sort of see, you know, make some changes as needed, and then the cycle starts over. So again, I'm not going to have you memorize that. That'd be kind of silly. And it's not necessarily anything, but this, in the general sense, this is a type of approach we're going to be taking. You probably take a similar approach for yourself, where you have some existing knowledge, then you gain new knowledge, and you kind of apply the knowledge and, you know, see how it worked for you. Probably don't take this rigid of an approach to analyze things, but, you know, maybe some people do. I don't know. Let's just kind of wrap things up today. We talked about various types of data, talked about why firms use data, some advantages that data management can have for firms, databases and all that, data warehouses versus data marts, and then organizational knowledge. Any questions about today? All right, make sure you do the Connect Master by 11:59 p.m. I hope you all have a great day.